Okay, let's just jump right in. We're unpacking the 2026 landscape of Wave 2 AI agent frameworks in this explainer. And look, we're talking about a massive fundamental evolution in how we build AI. The days of, just hacking together a few prompts and crossing your fingers, yeah, those are gone. We're diving deep into the frameworks that are literally rebuilding agent architecture from the ground up.
So here's a question I know you've asked yourself. What actually happens when your AI agent breaks in production? Because it will. You've been there, right? Wrestling with broken JSON outputs, invalid tool calls, maybe fighting the urge to just toss your laptop right out the window. It's a painful reality check. Building a slick AI prototype? Pretty easy. But keeping it running predictably in the wild? It's a complete nightmare.
And that brings us to the big paradigm shift we're seeing right now. We're officially moving away from Wave 1, which was really all about fragile prompt engineering, hoping these probabilistic models would magically spit out the right structure. Welcome to Wave 2. This is all about rigorous production-grade system engineering. We're finally treating AI agents like actual software, with strict architectures, robust testing, and hard, unbreakable constraints.
Here is our roadmap for getting out of prototype hell. First up, beyond the AI prototype. Then, engineering for reliability. Third, architecture and simplicity. Fourth, the context engine. And finally, composable intelligent systems. Let's get to it.
Part 1. Beyond the AI prototype. Let's talk about Pydantic AI and type safety.
Okay, so if you're the kind of developer who loves a beautifully well-typed API, this mental model is going to be right up your alley. Think of Pydantic AI as essentially the fast API for AI agents. You know how most frameworks treat structure like this optional afterthought? Well, Pydantic AI completely flips the script. It builds agents around types, validation, and pure correctness right out of the gate. It optimizes for schema engineering instead of prompt hacking, forcing deterministic structure onto models that are by nature probabilistic. It's an absolutely stark contrast. Think about the pure chaos of trying to catch errors at runtime, which is what you get with prompt hacks and endless glue code, versus the total confidence of compile time or write time guarantees. With Pydantic AI, if validation fails, no problem. The agent automatically retries under the hood until it nails the structure your Pydantic model demands. No more fragile JSON parsing. None. And it gets better. Instead of just kind of haphazardly wiring tools together, you're composing these clean, reusable capability bundles. We're talking tools, instructions, hooks, and model settings all neatly wrapped up. It feels way less like scripting and much more like engineering pure behavior. Oh, and it integrates natively with Pydantic Logfire, so you get instant observability to trace everything right alongside your perfectly structured outputs. Moving on to Part 2, Engineering for Reliability. Enter VoltAgent in Google ADK. So VoltAgent steps up and asks the really hard operational question. How do you actually run these things reliably in production? Because let's be real, building the agent is only step one. Think of VoltAgent as Next.js plus Datadog plus LangChain. It's a full-stack TypeScript platform that gives you both the framework for complex logic and the deployment platform called VoltOps to actively monitor and inspect every single step. It's the whole shebang. The declarative workflow engine here is just wildly powerful. You've got a supervisor agent that plans, it delegates to a specialized subagent, that subagent executes, and then naturally returns the result. VoltAgent just handles all that complex routing and state persistence for you. And get this, it even supports resumable streaming. That's a total game changer. If a user's network connection drops mid-generation, they just reconnect, and the response seamlessly picks up exactly where it left off.
But hey, for the hardcore back-end engineers out there, we have Google's Agent Development Kit, or ADK. If VoltAgent is Next.js, Google ADK is basically Spring Boot for AI. It aggressively treats agent development like real, testable software engineering. It completely strips away those hidden, magical abstractions that made earlier frameworks so frustrating, giving you clean, highly modular multi-agent systems built directly and explicitly in Python. The core features here are built for the enterprise. It's fully code-driven, meaning you version control and unit test it exactly like normal software. It's got native approval gates for human-in-the-loop safety, which honestly is non-negotiable for real enterprise workflows. It's cloud-native from day one. And it even lets distributed ecosystems communicate seamlessly across entirely different environments using its novel agent-to-agent, or A2A protocol.
All right, Part 3, Architecture and Simplicity. Let's look at the OpenAI Agents SDK.
You've probably noticed most frameworks just pile on layers of complexity to try and give you flexibility. Well, the OpenAI Agents SDK goes entirely the opposite direction. It is the minimal, clean abstraction layer. It zeroes in purely on composable, lightweight building blocks, agents, tools, handoffs, and sessions. This framework absolutely proves that you do not need a massive orchestration layer or some convoluted graph language to build highly dynamic systems.
The pure elegance of this approach is in the handoffs. Instead of wrestling with a sprawling orchestration engine, a main agent just takes a task, hands it off to a highly specialized agent, and gets the result back. Boom, done. This incredibly simple pattern is exactly how developers are standing up fast, low-latency real-time voice agents today, without fighting overly complex back-end logic.
Part 4. The Context Engine. We're talking Haystack and RAG architecture.
Because at the end of the day, your LLM's output is only ever going to be as good as its context. Period. So think of Haystack as the Apache Airflow for AI context pipelines. It's a highly specialized framework that treats context engineering and retrieval as a first-class citizen. While everyone else is obsessing over agent behaviors and tool calls, Haystack is heavily optimizing for pure, unadulterated information flow.
The key here is understanding chains versus pipelines. Black box chains hide what's happening behind overly simple abstractions. Haystack? It uses totally transparent pipelines. You explicitly define the components, the data flow, the routing logic, everything. It gives you uncompromised transparency. It actually feels like building a robust, debuggable data pipeline, rather than just throwing prompt hacks at a wall and hoping they stick.
By taking strict control over every single step, from document ingestion and retrieval down to ranking, filtering, and structuring, you can build seriously robust, enterprise-grade search and RAG systems. Actually, scratch that. You have to build them this way if you want to solve poor retrieval quality and unpredictable hallucinations in the real world.
Finally, Part 5. Composable Intelligent Systems. Let's talk about the philosophical shift.
So to wrap our heads around this new landscape, we have to stop asking, which framework should I use, and start asking, what kind of system architecture do I actually need? Need compile time guarantees? Go get Pydantic AI. Full lifecycle operations? VoltAgent. Speed and simplicity? OpenAI Agents SDK. Deep context control? Haystack. The builders who win this next era are going to aggressively combine these specialized layers. Think Pydantic AI paired with Haystack for a deeply typed, rock-solid enterprise RAG system. That is the future. AI agents are no longer features. They're becoming systems. This quote really hits the nail on the head. If you want to survive the brutal leap from a cool local prototype to a highly reliable production environment, your intelligence layer demands true architecture, rigorous observability, and really thoughtful software design. The days of a single default stack are completely over. Which leads us to the big question. Now that you've got the blueprints for the 2026 landscape, and you understand these incredibly specialized layers, from strict type safety down to deep context engineering, what kind of intelligence system are you going to design? The tools are officially here, the patterns are waiting. How will you build the future?